in number 2. The directions for number 2 say use the 5-step strategy for solving word problems to find the number or numbers described in exercises 1 through 10. Alright, so this book, every book has their own strategies, and this is, if you'll just follow my examples here, this is the strategy that I want you to use. Number 2 says, when 2 times a number is decreased by 3, the result is 11. What is the number? So in number 2, you're going to pick any variable that you like. My favorite variable is x. And in this problem, we're just finding a number. So you're always going to define your variables. So when they say use a strategy, the first thing is tell me what x is. And in this problem, it's pretty boring. X is just a number. Okay, it could be the number of movie tickets, but this problem is not very exciting. X is just a number. So always define your variable. That's the first strategy or the first process or the first step that you're going to do. Then you're going to write an equation based on the problem. When 2 times your number, and in this case our number is x, when 2 times a number is decreased by 3, the result is 11. This one's fairly easy. Can someone come up with an equation if x is my number for this problem? 2x minus 3 is equal to 11. They'll start off fairly simple, and then you know how this textbook does. They just keep getting harder and harder. And so your next step, after you write your equation based on your word problem, then you solve your equation. So this one's fairly easy to solve. There's no restricted values because there's no variables in the denominator. And I'm going to come up with x is equal to 7. Okay? So first thing that you have to do is you have to label your variable. Then you have to write an equation. Then you have to solve the equation. And then you have to go back and make sure that your answer checks with your original worded problem. So this problem says we're looking for 2 times a number decreased by 3. So if I take 7 and I do 2 times 7, I get what? 14. And then I decrease it by 3, do I get 11? Okay, here's the deal. You're used to taking x equals 7 and plugging it back into your equation. Why does it make more sense to take the 7 and go back to the word problem and make sure that that matches with the word problem? You may have written the equation wrong. Okay? So if you wrote the wrong equation and solved it correctly and checked your answer in the wrong equation that you solved correctly, does that mean your answer is correct? No. That's why you need to go back to the original worded problem and check it there. Because you could have written the wrong equation. Alright? When you're sure that your answer matches with the original worded problem, you circle your answer and you're done. Okay? So if you need to do some steps, step number 1, what did we do? We labeled our variable. Step number 2, we wrote an equation. Step number 3, we solved the equation. And step number 4, you can't really see that, so you might want to write step number 4, we checked answer with problem. Okay, we went back and we checked our answer with our problem. So there's actually 4 steps. I'm not sure what 5-step strategy this book uses, but 4 will get it. Label the variable, write your equation, solve your equation, check your answer with the word problem. Okay, let's move on to number 8. Number 8 says 70% of what number is 252? 70% of what number is 252? So again, this one's not very exciting. So I'm just looking for a number. So I'm going to label my variable. You must write an equation for every single problem in this section. This is about taking a word problem and converting it into an algebraic equation. Okay? If you can say, I can do that in my head, that's great and wonderful, but your directions are going to ask you to write equations for everything. That's what these strategies are. 70% of a number. So this is where you would have to take 70% and turn it into a decimal. Okay? Of means to multiply. So you're going to have 0.7 times x, and then it says we should get the number 252. So again, a fairly simple equation. They start out easy and they get harder. How do I solve that equation? I divide both sides by 0.7. X is 360. I go back to the original problem, and it says that 70% of 360, so I take my calculator and I do 0.7 times 360, and I make sure I get 252. Is 70% of 360 252? Okay? Once you've checked it in the original problem, then you know that you have the correct answer. Alright, next set of directions change a little bit. It says find all the values of x that satisfies the given conditions. These really won't be word problems. There's some words in here, but not a lot. This is where they give you y1 and y2. This textbook loves y1 and y2 problems. So number 10, oops, got ahead of myself. Forget about y1 and y2. Go back to number 10. One number exceeds another number by 24. The sum of the two numbers is 58. What are the numbers? Okay, this is not a y1, y2. I got ahead of myself. One number exceeds another number by 24. The sum of the two numbers is 58. What are the numbers? So we have to label our variables. Okay, so we have two numbers here. So I'm going to say x is the first number. And you do not want to use two variables. We're not ready for that. We could, but that's not where we're at. Everything in this section can be worked with one variable only. You do not want to use a second variable here. So whatever variable you choose, your equation should only have that variable. Now it tells us a comparison between the numbers in the first sentence. It says one number exceeds another number by 24. So if x is the first number, how can I represent the second number given that sentence? Do what? One number exceeds another number by 24. So if one number is x, the other number can be x plus 24. Does that make sense? I could have also used x minus 24. Does that make sense? One number has to be 24 bigger than the other. I like to use a plus anytime I can use a plus and not use a minus if I absolutely don't have to. So it says one number exceeds another number by 24. That means one number is 24 bigger than the other. So you have to define both numbers here. And then it says, what are we going to do with these two numbers? What's that three-letter word? Add. Okay, they didn't say add, they said sum, but you know sum means to add. So you actually have to add your two numbers. You have two numbers to add up here. So when you define your variables, you have to have x equals the first number and x plus 24 equals the second number. You're going to add up, sum up the two numbers, and you should get 58. You should get 58. Since I'm adding, I can drop those parentheses and combine like terms. That gives me 2x plus 24 is equal to 58. Solving for this should not be an issue. You're going to get 2x is equal to 34, and x is equal to 17. What are the numbers? Plural. What are the numbers? Have you found the numbers? Nope. You've only found one number. Okay? Is 17 the smallest number or the largest number? It's the smaller one. So what I like to do is I like to go back up here where I labeled my variables. This is really important. This is how you can use defining your variables. So x is the first number, so I'm going to write 17. So according to me labeling my variables, the next number is bigger. It's bigger by 24. So I do 17 plus 24 and I get what number? 41. So we're saying our numbers are 17 and 41. Does that make sense in the original problem? One number exceeds another number by 24. Does 41 exceed 17 by 24? Yes, and did the sum of those numbers 58? Is the sum of the numbers 58? Is there anybody out there today that can speak? Y'all are killing me. Goodness gracious. Any questions about number 10? All right, I'm moving on. I guess I'll just talk to myself today. Number 14 tells us that y1, this changes directions here. y1 is 9 times parentheses 3x minus 5. y2 is 3x minus 1. And then it tells us in the directions that y1 is 51 less than 12 times y2. y1 is 51 less than 12 times y2. This is just in your problem. You can just look at it in your book. I just want to have it up there so we can look at it. y1 is, they're giving you that. y2 is, they're giving you that. And then they're saying y1 is 51 less than 12 times y2. So this part of your problem right here is telling you about your equation. This is your equation part right here. So it says, what's the first part of that I circled in green? y1 is. So what is y1? 9 parentheses 3x minus 5. So that's what y1, that's y1. And then what does is usually mean if we're writing an equation from a word problem? Equals, good. Then it says 51 less than. This is what a lot of people get confused about. If it says 51 less than, then that means you're subtracting 51. It says 51 less than. So that means you are subtracting 51 from something. And a lot of people just write 51 minus. And the reason it's not 51 minus is because if you write 51 minus, then you're really adding 51. If you put a 51 and then you put a minus, and then whatever you put after the minus is what you are subtracting. So this says 51 less than. That means you're subtracting 51 from what? 12 times y2. And what is y2? 3x minus 1. So the hard part in this chapter, in this section right here, is just getting your equation. We've already practiced on how to solve. So we're not going to take time solving this one. So we're going to go zoop. We've solved it. Okay? And we're going to get x is equal to 2. We just want to work on, these notes are just going to work on setting up the equation. We've already practiced on how to solve. Okay? Now, if we take this answer and we go back and we plug it in, what would be the value of y1? If we take this answer and we go back and we plug it in, what would be the value of y1? Say it louder. 9. Okay? If we go back and plug it in, y1 would be 9. And what would y2 be? y2 would be 5. Anybody not know where those numbers are coming from? If you go back into 9 parentheses 3x minus 5, and you put a 2 in for x, 3 times 2 is 6. 6 minus 5 is 1. 1 times 9 is 9. Okay, and then if you go back into y2 and put a 2 in for your x, 3 times 2 is 6. 6 minus 1 is 5. All right, does this make sense? It says y1 is 51 less than 12 times y2. So that would be 9 is equal to, you tell me. Nine is equal to, okay, 12 times y2, which is 5, minus what? 51. Would that be true? is y1 equal to 51 less than 12 times y2? Well, 12 times 5 is 60. 60 minus 51 is 9. So that makes sense with that original problem. All right, moving right along. I'm just going to pretend that I'm in the room all by myself because y'all aren't going to talk to me today, and that's okay. You may still copying 14? Number 20. Number 20 gives you a graph. It says compared with Europeans and American employees use less vacation time. Compared with Europeans, American employees use less vacation time. The average time Italians spend on vacation exceeds the average American vacation time by 4 weeks. I'm reading under the bar graph. The combined average vacation time for Americans and Italians is 11.8 weeks. On the average, how many weeks do Americans spend on vacation and how many weeks do Italians spend on vacation? All right, so we're talking about two things. And they're wanting to know how many weeks do Americans spend and Italians. They're giving you the bar graph, but the bar graph has nothing to do with making an equation here. You have to read the word problem. So it says the average time Italians spend on vacations exceeds the average American vacation time by 4 weeks. So who takes more vacation time, Italians or Americans? Italians. Okay? So that's what we're going to have to label here. Okay, we're talking about Italians, and we're talking about Americans. So you're always going to label your variables, and we're really talking about weeks of vacation. Or let's just put weeks. We don't have to do vacation here. And we have to set up some variables that are talking about the weeks of vacations that the Italians take in comparison to the weeks of vacations that the American takes. And you have to use a variable here. It can be any variable that you want, but you have to label both of those things, and you have to use an X in both of them. Anybody know how you would do that? Okay, you're close. Okay, it didn't say that the Italians took 4 times as many weeks as vacations as the Americans. It said that the Italians spend vacation exceeds the average by 4. So that means more than. Okay, does everybody understand how you would do the original setup? Italians take more weeks of vacation than Americans, and then the problem, it says that they take 4 more weeks. All right, then the other part of the problem says the combined average time for Americans and Italians for vacation is 11.8. So what's combined mean to do? It means to add. So you're going to take the weeks for the Italian, and you're going to take the X, you're going to add those up, and you're going to set it equal to 11.8. Some of the things that we're preparing you for, these word problems sometimes make no sense. Why are we doing these? It's actually training our brain in order to take problems, process it, putting it into equations. A lot of times on the ACT, they just want an equation. They don't want the solution. They want the equation that matches the problem. So that's why we're practicing this. Okay? You can drop the parentheses and combine like terms and solve this problem. So we end up with 2x plus 4 is equal to 11.8. We're going to subtract 4 from both sides. We're going to get 2x is equal to 7.8. And then we're going to divide by 2. And I get 3.9. And we do have a unit here. These are weeks. Okay? We don't just need to say 3.9 weeks. I would like for you to go back up where you labeled your variables. And x is 3.9 weeks. So I like to go back up, and I like to write 3.9. I already have the word weeks here, so I could just actually circle this. So Americans spend on the average 3.9 weeks on vacation. And then how do I find how many weeks the Italians spend? I add 4 to that, and that gives me 7.9, and then I can circle that also. And then how can I check this with the wording in the original problem? Why do those two numbers make sense? Add them together and we get 11.8. add them together, and we get 11.8. All right, let's move on to number 24. We got time to do one more. Let's look at number 24. 24 says in 1986, 43% of the U.S. adults approved of men and women living together without being married. For the period from 1986 through 2007, the percentage approving of cohabitation increased on the average by approximately 0.6 each year. If this trend continues, by which year will 61% of all American adults approve of two people living together without being married? That's what cohabitation means. Okay, so if you're like me, when I read that problem, I don't know if you've ever read the Old Testament before, but I feel like I'm reading the Old Testament, and it made no sense at all, so I have to go back and read it like 5 more times. So in 1986, 43% of the U.S. adults approved of men and women living together without being married. Okay? For the period of time from 86 to 2007, is this percentage increasing or decreasing? It's increasing by how much? 0.6 each year. If this trend continues, the trend that they're talking about is the fact that people are approving it more and more. By which year will 61% of all American adults approve of cohabitation? Okay, so you're looking for which year. So you're solving for years. You've got to know years here. So that's what your variable is. And not only is it years, but it's years since. When did this data start? 1986. Okay? So when you find out what X is, you've got to add that back to 1986, and then that'll give us the year. Okay? So you've got to find X, which is years since 1986. What did we start with? How many percent of people believed it was okay for two people to be married, live together and not be married? Okay? We started with 43%. This is a problem that you can just use 43 because you're not taking 43% of something. You're starting with 43. All right? Is this number increasing or is it decreasing? It's increasing, so we're going to use a plus. And it's increasing how much per year? 0.6 per year, and we let X be years. That's what we said X was. And we want to know how long is it going to take us for how many percent to believe it's okay? 61%. So we're going from 43% to 61, and the 0.6 every year, more and more people believe that this is okay. So the trend is 0.6 people each year. So that's your equation. Okay? We would solve it. Solve, solve, solve. I'll tell you what I got here. I got 30. All right, this is 30 years, but I'm going to read the question to you. The question is, by which year will 61% of all American adults approve of cohabitation? So you can't say 30 years because it says by which year. So you take that 30 and you go back up here and you add it to 1986, and that will tell you what year 61% of the people are going to say it's okay to live together and not be married according to this data. And what year would that be? 2016. Y'all believe that that's true? Think more and more people think it's okay to live together and not be married? All right. Now, I'm out of time. You are going to do